Good morning, everyone. Today I'm going to work section 5.6 called Special Products. We're going to be talking about the square of a binomial and something called the product of the sum and difference of two terms. Now, nobody I know ever calls it this. Everybody calls it the difference of squares. We're going to be coming back to these formulas in chapter 6, and in chapter 6 they call it difference of squares. So if I were you, I wouldn't worry about learning this idea at all. What we need to do is, first of all, make sure that we see the difference between these formulas and this formula. This is from section 5.1. Here we had two numbers multiplied together, raised to a power, and we were able to take that power and put it on each one. Here we have a binomial. Things are separated by either a plus or a minus. And we do not get to just take this 2 and put it on each one. Okay? So we're going to be talking about these formulas a whole lot. The thing to recognize here, like I said, you have a binomial squared, signs in the middle. Notice these formulas are virtually the same. The only difference is this one has a plus and this one has a minus. For this one, we're multiplying two binomials. They have exactly the same terms. The first term is the same, the second term is the same. But we have a plus in one and a minus in the other. Now, you could do what we did in the last section. I had you mark two problems. For this one right here, 4w plus 7 squared, we rewrote it as 4w plus 7 times 4w plus 7, and then distributed combined like terms, and we got there. Okay? Yes, this always works. I promise you, you want to practice using the formula. It will help you out in chapter 6 immensely. So this is an example of the first binomial formula we had. Okay? We also marked the problem just above this, right here. This is an example of a difference of squares. We have the same terms. This one's a plus, this one's a minus, and we distributed. Notice our middle terms canceled out here. That always happens when we have this particular form. On this one, these two terms are exactly the same. They're both plus, whereas on the one above, there was a plus and a minus. Okay? So let's talk about these formulas a little bit. Okay, so let's look at 4w plus 7 squared. This is exactly the same problem we worked in the last section. This time we're going to talk through it by using the formula. Okay, now here's the way you can talk yourself through it. Okay, every time you go to square a binomial, you're going to talk yourself through this. Notice it's either a plus or a minus, and I kept it the same. The plus is in blue, plus is in blue. If you have a minus, you have a minus here. Okay, the first thing we do is we square the first term. So that means we are going to take, I'm going to write out every step here, 4w, and square the whole thing. Okay. We're going to write down the sign from the middle. This is a plus sign, so this is a plus sign. Okay. Multiply the two terms together. Okay, so I'm going to do this in another color up here. 4w times 7 would be 28, okay? And then we double that term. So that means we are going to take this and multiply this by 2 to double it, and that gives me 56w. I left out the w right here. W should be right there. Okay, so what goes right here is plus 56w. Okay? Plus the last one right here, if you look at your two formulas, this one is always a plus. So plus, then you square your last term. So this is 7 squared. Okay? Now, let's look at what we have here. Right here we have two things multiplied together, squared. We have property 3. This is a multiplication, so this property holds. Remember here, this is an addition, it doesn't work. In math, we have a lot of examples of where you have certain rules that work for multiplication and division, and then completely separate rules that work for addition and subtraction. Think about multiplying fractions. Okay, we have those rules, and then addition and subtraction need a common denominator. Think about our sign rules. Okay, we have certain rules that work for multiplying and dividing negatives, and they're different for adding and subtracting negatives. So this happens a whole lot. But what we do here is we square each term. 4 squared would be 16w squared plus 56w plus 7 squared would be 49. If you compare this to what we got in the last section, 16w squared plus 56w plus 49. Now what's happening here in that middle term where we said we multiply them together, this is where we did the 4 times the 7, that gave us the 28. And the reason we double it is because you always get it twice. If you have this form, you're always going to get this twice, so that is always doubled. This is your answer.